Alright, so let's look at creating our first particle. So to create a particle, we are simply going to go to our scene dock here and click on the plus to add a new node. And if I search up particle, you'll notice that there are a number of different options. We of course have our 2D particles here in blue and 3D particle related nodes in red. Now you'll notice that for both 2D and 3D we have two different types of particles. We have CPU particles and GPU particles, again both 2D and 3D. Now what's the difference between CPU particles and GPU particles? Well, essentially that just means where are these particles going to be calculated and run from? Is it going to be run from the CPU, your processor, or the GPU, your graphics card? Now, why would you pick one over the other? Well, CPU particles, their main benefit would be compatibility. If you're looking to build mobile or older devices that may not have a dedicated GPU, then CPU particles is where you would want, is what you would want to implement. But the downside is that they are of course going to be worse in terms of performance and features, okay? GPU particles is more of the focus that Godot is leaning towards, as CPU particles are kind of feature locked at the moment, and any new features added to Godot's particle system are only being added to the GPU particle nodes. And the GPU particles, they essentially run on your graphics card, meaning that their performance is going to be a lot better than CPU particles at the cost of potentially your compatibility. So again, if you're trying to build for older devices, or mobile or certain mobile devices, you may run into issues with using GPU particles. But if you are building for desktop or console as your main objective, then GPU particles are where you should go and are generally the recommended option. Now, they do work differently, so if you do want to follow along with CPU particles, you are going to struggle just because the workflow is quite different. In this course, we're of course going to be looking at GPU particles as they offer the most broad range of features, and they are really what Godot is looking to have users use in their engine. So we're going to go ahead and create a brand new GPU particles 3D node. Now, if you want to create particles for 2D, then of course you'll create the 2D version. And the good thing is that both of these are very similar, okay? You'll notice that if you're following along with 2D particles, it's essentially the same, except for the fact that we are not using the Z-axis, okay? But in this course, we're going to create 3D particles, but just know that creating them in 2D is going to be a very similar process. So I'm going to create a brand new GPU particles 3D right here. Now, we're not going to be creating any one of these specific particles right here. We are just going to create a test particle. So when we create our particle, you're going to notice a few things. First of all, you'll notice that there is this weird yellow box around the particle, around the node. This is essentially the visibility box. So as long as this box is within your viewport, then the particle is going to render. This basically makes it so that if we are looking out over here in an opposite direction, this particle is not going to be rendering, okay, just to save on performance. Now, depending on the type of particle you're creating, for example, rain, which might cover a large area, you might need to expand this box. And to do that, you can simply open up the drawing properties here and change your visibility AABB, okay, which basically can change the width, the height, and depth of the box, as well as its position. But for now, I think this is a good size if you're creating something like fire or sparks. Now, the second thing you may notice is that over here in the scene dock, next to our node, we have this little warning sign, and this is basically telling us that we have two issues. First of all, nothing is visible because meshes have not been assigned to draw passes, and a material to process the particle is not assigned. So what we need to do is two things. First of all, create a mesh for our particle to render, and then also create what is known as a process material, which defines how these particles behave. So first of all, if we go down to the draw passes property here, we can go down to pass 1 and click on the little arrow, and we can choose what sort of mesh we want our particle to be. Now, if you're using particles based on textures, for example, for fire or something like that, we are going to choose a quad mesh, okay? Now, a quad mesh is basically just a flat square, and as you can see, if I bring the particle up, it's going to be down here. Now, it's not really doing anything at the moment because we don't have a process material, so let's create one of those. Over inside of process material, let's go ahead and create a brand new one of those, a new particle process material, and you'll see our particles are now in action, okay? They are essentially falling down based on gravity. Now, if we open up the process material here, you'll see we have a bunch of different categories. We have spawn, animated velocity, accelerations, and all of these have their own subcategories. This is where you're going to spend the bulk of time defining your particle's behavior, okay? What color is it going to be? How is it going to grow over time? How is it going to move? How is it going to interact with the environment? The particle process material is that setting. Now, first of all, we probably want to change the size of our particle. So to do that, let's go down to where we have display and then scale. And then here you'll see we have a min and a max. Okay, a lot of the particle's properties are going to be a min and a max. The reason why is because you probably don't want your particles all to be the same size. You might want them to range randomly from a particle scale of 1 to 5 perhaps. So if I go ahead and change the min here to be 0.1, you'll see that our particles are all different sizes, and that is because our particles, when they are being spawned, are having a scale between 0.1 and 1. Okay, so it's picking a random number between those two. Now you may be thinking, okay, I want either less particles to spawn or more. Well, this is one setting that isn't here in the process material, but rather if we go up to the top, you'll see an amount variable. We can change that to be, for example, 100, and that is going to spawn 100 particles per second, or we can bring it down to something such as 2, and then that will spawn essentially 2 particles per second. Now, something else we might want that you may have noticed is that based on the camera's direction, the particles aren't facing us, because typically in games, particles will sort of rotate to face the camera, okay? That is known as billboarding. So to enable this, what we're going to do is we're going to go over to where we have the drawing tab on our particle and down to where we have transform align. We're going to switch this from disable over to Z billboard. Now you'll notice that our particles are essentially going to always be looking at the camera, which is great, okay? Now, another thing you may want is for the particles to not be so boring, I guess you could say. Right now our particles are just these plain old white squares, whereas over here in our file system we have a particle textures folder containing all these cool textures. So how can we use those? Well, over inside of our particle in the inspector, let's go down to where we have geometry. Inside of geometry, we are then going to create a material override. This is going to be a new material that gets applied to our particle. Now, inside of this material, we can basically fill it in how we would with a normal Godot material. So over here in our Godot, we can change the color to be pretty much whatever we want, something like that. Or if we want a texture, we can drag it into the texture property here. So let's go over and just find a random texture. Let's, for example, use this smoke. And there we go. We now have this texture being applied. But we have the black background. So to get rid of that, we're going to go over to transparency and change the transparency from disabled to alpha. Now we have a nice transparent particle here. Now we can also then go ahead and change its color to something like that. And yeah, this is just the basics of how we can set up a particle system. Between now and the next lesson, where we actually begin creating our distinct particle effects here, I recommend that you go ahead and just experiment with the process material, okay? Try some things out, undo those changes. There are a lot of things to modify. For example, in spawning, we can change the spawn area, we can change the scale, we can change then the gravity, the orbital velocity, the radial velocity. There are so many things that we can change here that I just recommend you go ahead and explore, or refer to the Godot documentation to learn more about it. But if you don't want to do either of those things, it is fine. For the rest of the course, we'll be exploring a wide range of different things here in the particle process material to create the particle effects that we want. So thanks for watching, and I'll see you all in the next lesson. Hey everyone, in this lesson we are going to be creating our sparks particle. Now the sparks particle is essentially going to be as if you had some electric wire and at the end it shoots off with sparks. Just add some ambience and some feel to your environment with these particles. So to begin, what we're going to do is we are going to create a brand new GPU particles 3D node. I'm going to rename it to be sparks. And then let's move over to the pedestal here, where the sparks particle is going to exist. Next, what we need to do is, if we hover over this little warning sign, we need to give it a draw pass and a process material. So over here in draw passes, let's go ahead and create our pass 1, which is going to be of type quad mesh, which is going to be representative of basically a 2D texture. Then up here in process material, we want to create a new one of those. And there we go. Now, for our spark, we probably want to use one of our particle textures here, okay? And if we scroll down, you'll see that there is actually some spark textures. So let's create our material. I'm going to go down to geometry, and then on material override, let's create a new standard material 3D. In here, we'll go down to our albedo, and for the texture, let's drag in one of these sparks. So what about this one? No, we want something a bit longer. Let's do this one right here, okay? This nice vertical spark. We then want to remove the black background. So to do that, we're going to go over to transparency, transparency alpha, and that is going to basically make the black be alpha or see-through or translucent, transparent I mean. So now we have a transparent background. So we have our particle here, we can even move it around and you'll see it spawning in particles, but it's not really behaving like sparks. Our sparks, we want to sort of shoot out from the center, up in the air and arcing over the sides, okay? As if you're using like a welder or something like that, or an angle grinder. So to do this, we need to go up to our process material and then over to velocity. Now, inside of velocity here is where we can define its start movement speed. At the moment, you can see right now, the velocity right here is at a minimum of 0 and a max of 0, meaning the particles aren't going to be moving at the start. Now, you may be wondering, okay, but they're falling down. That is because we have gravity enabled, so the gravity is pulling the particles down. But if we want these particles to sort of shoot out against gravity, we can change our initial velocity. So if I bump up the minimum here to be 5, you'll see that it is now going to shoot out the particles at a velocity of 5. Now, the reason why it is only going in the right direction is because our velocity direction property here is right now defined as 1 on the x, 0 on the y, and 0 on the z. So this is a rightwards direction. We want these instead to be sort of upwards and out. So to do this, we're going to set the direction to be 0 on the x and 1 on the y. Now you can see the particles are sort of being shot up into the air, which is pretty good. Now, I think that's going to be good for now. One more thing that you may be noticing is that the particles are kind of just stuck straight up. How do we make the particles sort of arc over? Well, to do this, we want to go up to where we have our drawing drop down and change the transform align over to Z billboard. Now, this makes it so that the particles can actually face the camera when we go around it, but it's still not rotating them. Now, to rotate them, we instead want to change it to Z billboard plus Y to velocity, meaning that its Z direction is going to be pointing to the camera and its Y direction or its up direction is going to be pointing in the direction it is moving. Now you can see it looks like this, which is pretty cool. Okay, so we have our particles sort of shooting out and then going at angles as they fly outwards. Okay, so we're slowly getting there, but there's a few things we need to do. First of all, the particles are pretty big, so they look kind of strange when they arc over. So let's go ahead and actually change our scale. So down in our process material, I'm going to go down to where we have display and then scale. Now, for our starting scale, let's just set this to be 0.2 on the min and the max so that we have this much smaller looking particles here. And let's also bump up the emission rate. Okay, so if we go right to the top where we have amount, let's change this from 8 to, we'll go 100. How about that? So now we have a lot more sparks shooting out. Now, I think the main thing that we then want to do from here is going to be actually changing the appearance of the spark, because right now they just have that default white texture which doesn't really look like sparks, kind of looks like confetti or snow being shot out from somewhere. So what we're going to do is change the material's color. So if we go down to the material, go to its albedo color, we can change that to be a sort of yellow, okay, something like this. Now that's pretty good, but it still doesn't look like sparks. And the reason why is because of the emission. Okay, right now we just have a base color. which is good for things maybe like dust or that, but if we want something that is light, that emits light, we want to have it have a vibrant bloom appearance. So if we open up the color again, you'll see down here there is an I slider, and this stands for basically the intensity. So if we bump this up, you'll see that our sparks are going to get brighter and they're going to sort of shine. And that is because of the world environment node I'm using. It has bloom enabled so that we have this nice sort of effect here. Now we can adjust the color further until we find something that we like exactly. Okay, so feel free to adjust it slightly more, maybe like that. We'll try and have like white on the inside and then the yellow on the outside. There we go. And yeah, now our sparks are starting to look a bit more real, I guess you could say, with this nice white glowy effect. Now, there are a few more things we need to do for our sparks. The first thing is going to be making it so that when the sparks are destroyed, they don't just disappear like this, okay? With sparks, generally they fade out as they're being shot. So a way we can do that is by either changing the color to fade out to basically transparent, or we could shrink the particles over time. I think we're going to shrink the particles over time, as that will also give us a look at curves. So if we go down to where we have our scale display right here, you'll see we have a thing called a scale curve. Now if we go ahead and create a new curve texture and open it up, you'll see we have this curve right here. Let's click on that to open it up. And if you've ever worked with curves before in Godot, it's basically the same editor. But essentially what we can think of it is our particle's lifetime. On the 0 on the left-hand side is when it was created. And as we go along the x-axis, this is its entire life until when it reaches 1, which is when it basically gets destroyed, okay? Because our particles have a set lifetime. And the y value is going to be the scale. So right now it is at 1, which stands for basically 100% of its scale across its entire life. But if I click on the node on the right and bring that down, you'll see that the scale is now going to decrease over time. And if we look at our particles, that is exactly what's happening. Our particles are starting in their normal size, and then as they continue on, they are shrinking down over time. We can adjust this as well to however we see fit. And yeah, that is how we can add in our particle scaling. Now, in the next lesson, we are going to be looking at adding in collision, because right now, if we drag our particle down and maybe extend its lifetime a bit, to extend the lifetime, we simply want to go up to where we have time and then set a lifetime to maybe be something such as 2. Now you'll see that the particles kind of just keep raining down. What we want to do is instead have these particles bounce off the ground and slide across it as sparks normally do. So that's what we're going to be looking at in the next lesson. Thanks for watching. Welcome back everyone. In this lesson, we are going to be looking at particle collisions, okay? Because right now, our sparks, they're spawning and they're kind of just falling through the ground. Now, typically with sparks, you'll notice that they kind of slide and bounce across surfaces to give them that nice kinetic effect. So what we're going to do is make it so that our sparks can interact with our floor. Now, to do this, we have to create a new node. So if we go up and create a node, you'll see if we search for particle, it'll pop up with these right here. GPU particle collisions, okay? We have collision boxes, height fields, spheres. Now we're going to create a GPU particles collision box 3D, create that, and this is essentially a collider for particles. Now I'm going to bring this down, so basically the top of this square is going to be level with our surface, and then I'm just going to change the size property here to be maybe like, let's just say 50 by 50 on the Z, so we have this nice big floor right here, and then you'll notice that our particles, well, they're not colliding still. The reason why is because we need to enable particle collisions because, again, this is a check that isn't entirely cheap, so I wouldn't recommend adding collisions for every particle in your game, only when needed. So on our sparks particle, let's go down to where we have collision, okay, in our process material. And we want to set the mode over to rigid. Now you'll see there are two different modes, rigid and hide on contact. Hide on contact basically means that when the particles hit the collider, they will be destroyed. We don't want that. We want to make it rigid, which basically means these particles are still going to exist, but they are going to now interact with that collider. And as you can see, by default, these particles are just going to hit and slide along. Okay, it's going to try and maintain that velocity that it had before. Now this might be alright, but I think this looks like little insects crawling away rather than sparks. Okay, sparks, we might want to add a bit of bounce. So over here to bounce, what we're going to do is bump this up. And as you can see, we now have some bouncing sparks, which sort of hit and bounce across the surface, which definitely makes it look quite cool and pretty much like sparks. If we bring this up to a bounce of 1, that essentially means it's going to maintain its velocity with every bounce, which does look a bit strange. So let's bring this down to maybe 0.5. Okay, something like that. Now, sparks are also generally fast, okay? And right now our sparks aren't that quick. So what we need to do is increase their speed. So let's go up to where we have our velocity, and I'm going to set the min velocity to be 5 and the max to be 8. So now our sparks are going to be flying out at a much quicker rate. But again, this looks kind of chaotic. So a way we can make the sparks feel like they're sort of coming down at the surface quicker is by modifying our gravity. So if I go down to where we have, let's just close display and spawn for now so we can tidy it up a little bit. If we go down to where we have accelerations and open up the gravity drop down, you can see our gravity is right now set to Earth gravity, minus 9.8 meters per second per second. Instead, I'm going to bring this down to minus 30, okay? And as you can see, our sparks look a lot more kinetic, a lot more frantic, you could say, which is pretty much what you want. We could actually maybe bump this up to minus 25. And yeah, there we go. That is our spark sort of shooting out like so. Now, if you want to change how the particles are sort of shooting out from the top, we can open up spawn, then down to velocity, and change the spread variable. Now, spread essentially means what is the maximum offset from this given direction, which is basically up, can the particles be shot off in? And right now that is set at 45. So the largest angle from up away from it that you'll see is going to be 45 degrees. If I increase this, you'll see that our sparks at about 100 degrees now can spawn pretty much in that wider angle range. Or if I bring this down to 0, the sparks are only going to be shooting upwards, which gives this strange effect here. But if we bump this up to something like 20, we can have an effect like that. Or we can bump it back up to 45 to have what we had before, okay? But feel free to experiment with all of this, as it's definitely going to change the look of your particles. We can also then maybe increase the amount, so we can even say, for example, 1,000 sparks per second, which looks pretty crazy. I'm also going to bring the lifetime back down to 1, just because we don't really want the sparks going on for too long, as they do want to sort of fade out over time. I'm just going to bring the amount down to 200 to keep it a bit more manageable. But there we go, we have our sparks. Now, if we go ahead and press play, we can go over and have a look at them here in game. And our sparks, they look pretty crazy, look like they would burn us if we get too close, with the particle bouncing. And yeah, so that is our sparks particle set up and ready to go. Feel free again to experiment with this further, adding in differences. If you want a bit of an open-ended challenge, try and make it so that the sparks start off their color as white and then get darker into a more yellowy hue as they continue on in life. I'll give you a hint on how to do that. We can simply go down to the process material, go down to display, and if we go down to color curves, we can change the color ramp, which is essentially going to be a gradient that changes the particle's color over time. All you need to do for that to work is to go down and set the particle's default color to be white, and then up here in vertex color, enable use as albedo, and that will allow us to then modify the color in the process material. So that's a bit of an open-ended challenge and an optional one at that. We will be looking at color ramps later on in the course, so if you do want a better understanding of how they work, we will be covering these momentarily, okay? But yeah. Also, feel free to just experiment with a bunch of other things. If we go to accelerations, for example, and change the, let's just say, the radial acceleration, you'll see this can provide a quite strange effect of particles sort of shooting around, orbiting around, kind of like that. So yeah, it's just fun to go around and mess with all these different settings. Also, if you hover over them, you can see that for most of them, they will provide a little explanation on exactly what they do. Okay, so do have a look at that as well. So thanks for watching, and that is our Spark particle looking at particle collisions.